Hey everybody, this is Garrett with Earth and Time, and today I am so excited to take you all with me to check out Dinosaur Ridge in Morrison, Colorado, just outside of the Denver region, and one of the best fossil track sites. In fact, rated the #1 track site in all of North America. So excited to take you all to Dinosaur Ridge. Let's get to it. And check this out, it's a Stegosaurus right up front. Stegosaurus being the state fossil. I don't think we're going to see any of the trackways from Stegosaurus, but we will most definitely see trackways from iguanodons. And they have a Triceratops here, a Ceratopsian. Unfortunately, we aren't going to see any tracks of those either. Both the Ceratopsian and the iguanodon lived in the Cretaceous. Ceratops was living when the asteroid actually hit at the extinction of the dinosaurs. I mentioned the age of the Ceratopsian and the Hadrosaur. However, I didn't mention it for the Stegosaur. The Stegosaur would have been around during the Jurassic and were extinct by the time the iguanodon was around, or Hadrosaur and the Triceratops. They do have an exhibit hall here, and you have this guy trying to get me. Look at that. So the exhibit hall is $4 per person. They do have bus tours that'll take you from stop to stop. And I did the audio tour, which was $8, and very, very worth it, I think, to do that. And you can walk to the different sites and take a look. So as we talk about the different times, we're going to talk about the Morrison Formation 150 million years ago. We're in this area roughly, and this was where there were a series of, as a continental environment, there were a series of rivers and lakes, and eventually what this water body will eventually become the Cretaceous Interior Seaway at about 120 million years ago, working its way down south until it eventually connects right around 100 million years ago. It'll connect all the way through, and the track sites that we're going to look at today are associated with kind of that 100 million year time frame. However, things like the Stegosaurus and Apatosaurus, and of course my favorite dinosaur, the Allosaurus, would have been living during this time, and we're going to see some bone beds and actually be able to look also at some sauropod tracks on the other side of the ridge. As we look at the trackways, one thing to be aware of is we're going to see where these hadrosaurs walked on ancient beaches about 100 million years ago, and we're going to see what's known as the pes, the back foot, and the manus in the front foot, and we're going to be able to see where those stepped, showing that they actually walked on all fours for periods of time. Now, there's probably tracks that are going to show them walking on 2 feet too, so it maybe depends on what they were doing. It's going to kind of look like this. And we're going to see some evidence of sauropods, or these long necks as well. I always think of the Sinclair dinosaur from the gas stations would be a sauropod, but we're going to see where sauropods stepped into the mud as well. Most of the trackways we're going to see are actually from 105 million years ago, the early Cretaceous, when this Cretaceous Interior Seaway was working its way through. Eventually would connect and split North America into a western and eastern portion. And the type of dinosaurs we'll see during that time, footprints from, are going to be these iguanodons, as well as the coelurosaurs, which are a type of a basic ostrich mimic. And this is cool. They actually have trackways from T-Rex, and they know it's a T-Rex because of this little dew claw back here. Now, we're not going to see any T-Rex trackways here, but really cool that they have a model of one, and they have a track impression of a T-Rex track right there. Actually from New Mexico. Really, really cool. All right, let's go ahead and park and start our hike up Dinosaur Ridge so we can actually look at some of those trackways and take a look at some of the amazing geology there and talk about the evidence for how we know about the Cretaceous Interior Seaway and how we know about what the Earth was like during the time of the dinosaurs. And this will just give you an idea about the trail we're going to go on. So we started here at Dinosaur Ridge Visitor Center, and then you'll see it's about, 0.3 miles. I'm here right now at this sign so we can see where we're at, and we're going to follow this down another, says 0.3 miles, to go look at Crocodile Creek, come down to the main track site, and then it's going to be about half a mile to get around to the point, look at the Brontosaur bulges. So this is where we can actually see where Brontosaurs stepped and sank into mud. Looks really exciting. We can actually see a bone bed, and then we'll work our way down here. It looks like the Dinosaur Ridge Discovery Center, or the Martin G. Lockley Center, is actually closed right now. I'll double check that as I work my way around, but we'll come here and then work our way back. So this gives you an idea about this Dinosaur Ridge park. Let's go check out some track sites. To get us set up with where we're at, the city of Denver actually lies over that hill. We parked down at the end of the road there. The museum with the dinosaurs is down over there. But what I want to show you is the geology we're going to be walking through today. And we're going to go as far back as the late Jurassic, where, as we learned, they found Allosaurus and Stegosaurus. Stegosaurus, again, being the state fossil of Colorado. But we're going to go through the Morrison Formation, which is probably the most famous formation for finding dinosaurs. And where I'm standing at the sign now, we've moved into the early Cretaceous. So this is about 145 to 100 million years ago. And this is things like early duck-billed dinosaurs, raptors, and ankylosaurs. And of course, by the time we get to 65 million years ago, this is when the meteorite impact happened and dinosaurs went extinct. And you'll see the start here of what they call the Laramie. The Laramie is the big mountain building event that actually built the Colorado Rockies. I don't know if anybody can see up there, but let me zoom in. There's actually a deer walking up along the fence line. And the deer is actually walking right towards me. So I'm going to stand here and let you all check out this beautiful deer that's up there. Hi, deer. You see any dinosaur tracks up there? All right, back to the rocks, the real reason we're here. We can see what was known as the Western Cretaceous Interior Seaway, and that was a seaway that actually cut North America in two large islands, basically separating here close to Colorado. So during this time, we would be sitting somewhere right in this area, and that's what we're seeing deposit here are a bunch of what we call mudstones or shales, and this would have been fine-grained material that was deposited within this interior seaway. So think about, deep areas in the ocean, getting lots of muds. Fossils are found in here, everything from various types of shells to ammonites, like the ammonite we see here, similar to a nautiloid. And there have been fossils of plesiosaurs and mosasaurs, so basically swimming reptiles, these are not dinosaurs, that have been found within the Cretaceous interior seaway deposits as well, although, as I understand it, not here along Dinosaur Ridge. This area where I'm staying at today would have been under meters and meters or tens and tens of feet, if not hundreds of feet of water. And that's where you'd have all this mud deposited. And you'll see how it comes off kind of platey, which gives us the impression that this is finer grain material here. And actually I can touch it. And one of the tricks to find out just how fine grain it is I can rub it against my teeth a little bit. And if it's super smooth, yeah, spit that out. If it's super smooth, then I know it's all mostly mudstone. So maybe I'm a little deeper out in a deposit. This actually is a little silty. So I hit my teeth with it and it's actually got a little bit of grit. So this probably sat a little bit closer to the shore than some of the deeper muds that you think in kind of what we call the abyssal plains. As I'm working my way up, I can actually see a change of layers. So we have that bentonite shell that's over here, the muddy stuff, and now we're starting to see a change to something that looks a little bit more tan and buff colored, and I'm going to guess is a little coarser as we come around on the side. In fact, what you can start seeing are layers of sandstone interbedded with some mudstone still. So this is where you have a transition from out deeper in the ocean towards more of a shoreline. And sure enough, as I start walking this direction, I actually can see a lot more sandstone. And here we go. We are into what's known as the Dakota Sandstone. This is a large body of sand that used to be once a gigantic beachfront as the water kind of moved its way west, then back to east. It's all part of these beach deposits in the Cretaceous. Which means, seeing that sign, I'm getting excited to check out the dinosaur tracks and learn about where dinosaurs were hanging out on the beach. I wonder if they had umbrellas. Did they bring beach balls? What did dinosaurs do at the beach? What would you do if you were a dinosaur at the beach? All right, this is awesome. There's this little sculpture here, interpretation of an iguanodon or a duck-billed dinosaur relative. And you can see where we're at in geologic time. So right about that 100 million year mark. Apparently 100 million years ago, there were a lot of crocodiles here living along the shoreline, along with the dinosaurs. And you can see the iguanodons there in the background. And using my shadow, you can see the crocodile toes here. They actually said there's a lot of crocodile trackways here. Crocodiles were very abundant in this area in the Dakota about 100 million years ago. If I zoom in here, I'm going to use my finger, you can see where the crocodile scratches are there. They've interpreted this as crocodiles were moving their way along the beach here, and those would be crocodile scratch mark. We can see the ripple nature of this. So ripple marks is what we call these, and or we can see the shorelines coming in and out. And with that, this allows us to interpret the environment these crocodiles are living in. Now, of course, they're crocodiles, so crocodiles live near water today. They lived near water 100 million years ago. We can put all those together and get an idea about what we call the environment of deposition, or what kind of environment were these crocodiles and dinosaurs actually living in. And with that, there's actually invertebrate impressions that also help us tell that story. So these little features here, which you can see the iron staining around, were little burrows by things like worms and shrimp, maybe some other types of crustaceans. Clams maybe were in here, or maybe there's animals trying to eat the clams that were in this section. And you can really see kind of the pockmarked nature also of some of this. So these were probably all little worm burrows that were in here that these worms were feeding. Just like you at the beach today, you'll see little sand crabs and other creatures living right along the beachfront, getting the nutrients there. They would have lived in the same kind of sandy substrate like we see today. The other thing to give us an idea about what kind of world these animals were living in is we look for other evidence. So in this case, they actually have an impression of a branch. So we can see one limb here, we can see the other parts of the limb going back and forth here. So it tells us that there were fairly large trees growing somewhere in the general vicinity of where these crocodiles and these shrimp and other creatures were all living. In fact, we can see impressions from a lot of trees that have all now eroded out, but also very interesting. I don't know if I've ever seen tree impressions quite like this before. All right, here we go up the hill. Oh, look at this. Look at this. We have found some dinosaur tracks. And what they've done here is they've actually painted where the dinosaur tracks are. What we have are at least two different dinosaurs here with different size tracks. We have a large track right in my shadow, another step here, and then that one's going that direction. So it's going 1, 2, 3. And then I wonder if that one turns and we see it over there. But then there's another set that are slightly smaller working through here. So I wonder if this was mother and child, or just two that were part of the herd migrating through this area. But really neat to see those trackways. Now, one of the reasons trackways fascinate me so much is we've all seen, fossils from dinosaurs, the bones that have been preserved. But all the bones do is tell us what they look like. They don't actually record behaviors. I really like trackways because it's actually recording what dinosaurs are actually doing, and really gives us a glimpse into the life of a dinosaur, not only from how they were walking, in this case they're walking at least a pair of them, so traveling together as opposed to isolated or solo, but it also, we can learn about the environment that they lived in, because we can see where their tracks were and then interpret, okay, they were walking along a shoreline here. We have some really interesting features in front of me, and one that I've never seen before, and you'll see where it says theropod scratch marks. They believe these are scratch marks that were dug in by a theropod, maybe even in some kind of mating ritual or dance. And we can see a set there. We can actually see some possible scratches over on the other side. Really, really interesting. And apparently birds do this today. Birds may have inherited this instinct to kind of scratch in a courtship type pattern, which is what we see pictured here, where these theropod dinosaurs, meat eaters, but whatever kind of meat eating dinosaur, they would have scratched here maybe as a display for courting. Really, really cool to see. All right, everybody, this is the moment I've been waiting for. This is the Dinosaur Ridge Tracksite, which is considered the best and most well-preserved track site within the entire United States. In fact, I believe even in all of North America. I'm a bit like a kid in a candy store, which a gentleman was just walking past me, talking to me, and he says, "You really are a kid in a candy store here." And I said, "Absolutely. I get to go check out the #1 track site in all of the United States and all of potentially North America right here, right now with you all." I'm so excited. All right, aerial view of America's #1 dinosaur track site. 39 individual animals made more than 250 footprints. There's 3 dinosaur species representing herbivores and carnivores, so plant eaters and meat eaters, and there's 1 crocodilian. Wow! Look at this. Look at this. I know it's hard to tell scale from here, but I'm just under 6 feet tall, and this is probably 3 or 4 of me going up. So pretty impressive surface here that's been exposed. And because it's up on end, because of the thrust faults here that set this up in the Laramie orogeny, that mountain building vent that popped up the Colorado mountains, you can't ask for a better exposure of tracks to study in this kind of view. I think the hard part is to figure out where do we start talking about what we're looking at here. Let's talk a little bit about the fact that we see a lot of tracks here. They said 250, but let's talk about what these dinosaurs were actually stepping in. And they actually think they were in these fluctuating sea level areas. And so these may have been like muddy sections along the beach. And so as they stepped into the mud and then sand came over on top, it actually was able to preserve them. There are a couple different types of creatures over here. You'll see there's ornithopods. So these are going to be like our duck-billed dinosaurs, our hadrosaurs, and these are going to be some kind of theropod. And you notice that those toes look a lot like what we think of an ostrich or emu today, and those are going to be more closely related to something like this middle creature in here. And you can see where you have the iguanodon up there, and you can see whatever these ostrich-sized omnivorous dinosaurs were. And then we'll actually look at some crocodilian tracks, which we've seen some versions of those already. However, these crocodilian tracks are really, really obvious. You can see where a crocodile is walking through and how the toes look so different than what you're seeing up here with the hadrosaurs or the duck-billed dinosaurs, or what you're seeing with these meat eaters. Now, again, one of the things that's really fascinating by this is you can actually see, in some cases, you see the back foot and the front foot of the hadrosaur. Sometimes it looks like they're walking upright, bipedal on 2, and the other times they were quadrupedal and walking on all 4s. And you'll notice the curve and the shape of their front hand. So again, why I'm so excited about dinosaur tracks is, like the sign says, we actually get to learn about dinosaur behavior. We get a glimpse in, as they say, a day in the life of these ancient animals. What were they doing? And you'll see there's groups of them walking various directions along the shoreline. Is it one herd coming and going? There's a multiple herds here. Were the theropods following someone, zigzagging through, trying to find some of the smaller iguanodons maybe to eat? Or were they looking for some fish or something else along these shorelines? And so whenever you think of a trackway, think of, wow, we're actually recording what ancient animals were doing at that moment in time, 100 million years ago. In this case, I'm just blown away by it. What's also nice about this spot as a geologist is I can really get an idea about the environments here. And they were in a slightly different environment, the dinosaurs, stepping into this grayish layer with this little bit of iron staining on it again that you can see. And this would have been a slightly muddier layer, which they talked about before, but you can compare this kind of grayish color and slightly finer grained compared to the buff colored sandstones immediately to the left. And so these sandstones came over top, preserved these tracks, and through time, as they were both building a road through this area, they exposed these tracks in the 1930s. And unfortunately, those original tracks were destroyed. But what they found is, as erosion continued to happen, they actually found more and more of these trackways that were underneath and preserved by these sandstone units. And then as these mudstone units or siltstone units started to weather away, they were able to identify each of these trackways. Really, really cool story, and I'm glad that they've preserved these for all of us to see. I'm not sure where we're supposed to go from here, but let's keep trucking along Dinosaur Ridge and see what else we can learn. This spot, they actually talk about some of the evidence and observations about what was living in this muddy substrate these dinosaurs were walking across and crocodiles were on. And basically it says shrimps, worms, and other crawlers burrowed into wet sand and mud, leaving behind squiggles, bumps, and blobs. Let's go take a closer look at some of those. And we can see where this track is at. It's a very poorly preserved track, but there's a track right there. But we can see how the surface is all chewed up and looks very different than the other surfaces we saw. And so these would have been ancient worm burrows or crustacean burrows that were digging in this muddy substrate as water came over it. And it's preserved along this whole face, telling me this was a large, muddy, just off the shore beach deposit, or maybe kind of a tidal area where all these creatures were living in and these dinosaurs were walking through. And here's another area with some fantastic ripple marks. And what's interesting about these is notice they're lined up in a different direction than the ones we saw earlier, which were lined up almost perpendicular to these, telling me that whatever was happening during this time with the water, it was coming from this direction as opposed to from this direction during deposition. I made it to the apex of the trail up here, and there's some fascinating geology that you can see from this vantage point. First, the city of Denver is out in that direction, and we can see how everything gets pretty flat looking towards the east as opposed to looking towards the west. So we're at the edge of the Rockies right here, and the edge is formed by a thrust fault that runs down through here and has turned these beds over kind of like this, so they're flat. A thrust fault went up through, rotated these beds over, and eventually they eroded. And when they eroded, they actually ended up with little spires or ridges sticking up, and we can actually see those ridges of the Dakota, which is what I'm in right now, continuing all the way down there, giving us an idea about the shape as well of this thrust fault, which would be sitting somewhere out in the valley in front of us. And if I turn around and look the other direction, I can really see those dips coming down. And if you remember, things get younger going this direction on this hill, older as we go in that direction. We're going to now move from the Cretaceous and work our way down into the Jurassic in what's known as the Morrison Formation. And we can see little peaks of red rocks behind us. So we're actually not far from what's known as a red rock amphitheater, and we'll see if we can get a look at that as we walk around this corner. As I'm walking through the gap to the left over here, what we can see are all these beds dipping down. And so when beds are originally deposited, they're generally deposited flat because of, well, gravity, because it's hard to maintain a slope if you're loose sediment. You can look at beaches today and see that they're pretty flat, and we've already looked at this material and know that was some sort of beach. So we know they started out like this, and now they've rotated about, I don't know, 20 degrees or so, maybe a little bit more. And this tells me that there's some kind of event that took place here, and we've already talked about the thrust fault that needs to be out here that formed the Rocky Mountains during the Laramide orogeny. The other thing that was happening during this time is there were a series of volcanoes erupting here in the early Cretaceous. Now, the important part about recognizing where a volcanic ash is at is because ash often contains volcanic material, contains uranium, and uranium decays at a very specific rate that we understand based on chemistry. And so we can come look at this ash layer, take samples from it, and find out how much parent material, the uranium, has been converted to lead, the child material. And because we know that decay rate, they can actually date this layer. And this layer right here has been dated at 104.6 million years old. So that tells us that these rocks and the sea was here during that time. Not always able to make those kinds of observations, especially where they've actually dated an ash layer in the area to help constrain the geologic time for this material. Walked through the gap now, and what we can see off in the distance, for those of you who are concert music fans, is actually the Red Rock amphitheaters right there. And that material is called the Fountain Formation, and those are Pennsylvanian to Permian sandstones from before the time of the dinosaurs. So as we're walking this direction towards the mountain, towards the west, we're actually getting into older rocks. And eventually, somewhere in the vicinity, and there's actually what is known as the Great Unconformity, where you go from rocks that are hundreds of millions of years old to something that's 1.7 billion years old. And it was a time of mass erosion across much of the planet. And we actually looked at some of that together in a video I did at Frenchman Mountain, and I will link that up here. All right, as I walk over here, it says there's rare raptor tracks. So how do they know a raptor track from other track? Well, Raptors will have one claw up and two down, and then their little or dew claw in the back. And so what you'll see is actually just two tracks, and you'll be missing that third like we saw at the other track sites. And there they are right there in that red circle. And what's really cool about this is I think Jurassic World is coming out today as I'm standing here thinking about the Jurassic Park movies that of course put velociraptors on the map. We can actually see trackways from one of the velociraptors right there, and you can see the two toes and how it doesn't have a third toe in the mud because again that third toe was in a claw, and they would have had it up and out of the mud. And this site is only one of 12 in the entire world. How flippin' cool is that? Okay, so I got to get a picture of me with the raptor track behind me because I'm so excited about that, and it's like seeing a celebrity to me. And the fact there's only 12 of these in the world, and I'm standing in front of one of them, just wow. Now I'm crossing into a change here, and I think that change is related to that's our Cretaceous material, and I'm guessing this material that we're coming into is going to be the Morrison Formation, which is Jurassic. I've got to say, Colorado is absolutely stunning, and the views are amazing. Now, the reason that we have this valley to walk through is because of the Morrison Formation and finer grain geologic units that were able to erode out and create this valley between the Dakota Ridge here, which is very resistant, and the Fountain Ridge and the Proterozoic rocks on the other side, which creates this nice, beautiful, even fertile valley. Whoa, take a look at this. It's a cross-sectional view of where a dinosaur stepped in mud and sank. And so you get an idea about the size and weight. So think about a big truck going into some kind of mud, or if you jumping in a muddy puddle that's got a lot of mud at the bottom, how you would sink in. These creatures were so large that they're creating a step, and then I can come over here and another step. And these are about, I don't know, 5-6 feet apart. And then you can see another step, and you can see another step. And then you can see the mother of all steps. Look at the size of that. What kind of creature can make something that large and sink that deep into the mud? Our friends, the sauropods, things like a Diplodocus and a Podosaurus, one of these long-necked dinosaurs that would have been absolutely gigantic. And we can see I was right. We are in the Morrison Formation now, about 150 million years ago. So we've now crossed from the Cretaceous, the late stage of the dinosaurs, to the middle time of the dinosaurs, the time of things like Allosaurus, Stegosaurus, and of course, these large sauropods, the long necks and whiptails. Okay, this Dinosaur Ridge just keeps getting better and better as I go along. I thought I was blown away by the raptor, absolutely, but actually see a cross-sectional view of where a sauropod was stepping and sinking down into the mud and get an idea about the sheer size and weight of one of those. Wow. While we're walking through here, let me talk a little bit about the Morrison Formation. The Morrison Formation was a time, it was terrestrial, so it was on land. There was a series of lakes and rivers, lots of volcanic eruptions were occurring, which will give the kind of greenish colors we sometimes see, and even some of the reds that we'll see here. And there's the sign for the Morrison Formation. But it really gives us an idea about what was happening during this time, different than what we were seeing in the Cretaceous along the shoreline. A lot of these animals were living along rivers and lakes. Of course, the Jurassic is very famous for things like Allosaurus and Stegosaurus. And of course, I mentioned before the sauropods. And take a look at this track and look how it's different from the tracks we were looking at before. So this would be a theropod track. And the reason we know is we can tell by the digits. We can actually see the nails, the claws, right? This would have been some kind of meat eater. Now, what kind, I'm actually not sure during this time in the Morrison, but it is neat to see this block here. And this was probably deposited along some kind of river this creature was walking along. Now, the Morrison is one of the most famous, if not the most famous bone bed, specifically here in Colorado. So this is where things like the Stegosaurus came out of. And this was also the home to what was known as the Bone Wars, where paleontologists were racing against each other to make the best discoveries in the late 1800s and the early 1900s. So this Morrison Formation is one of the key formations for understanding dinosaurs. I think we are coming up to our last stop on this tour, which is to actually see some of the bones that are still within the rock. As I was mentioning, that The Morrison is a famous fossil locality, and you can actually see some of the bones here. I don't want to touch them because I don't want to erode them out, but we can actually see a large bone here, and we can see pieces of bones here, all within the sandstone, probably a river deposit. In fact, I can tell it's a river deposit in the Morrison because much like a river, I can see these layers pinching out eventually. So you can see this thing thins and pinches, which is exactly what we see in a river, right? A river channel. So we're looking at the edge of the river channel here. It's getting a little deeper as we go here. And I'm not sure, it looks like maybe it pinches back out on that side. So this was a little river that was coming down that carried these bones, and they were actually deposited. Just so you all believe me, here we go, burying bones. Of course, they have this on the other side where I was talking about this idea, but this is exactly what I was talking about, is that you can actually see the shape of the river, and as the river flows, it's depositing these bones. You'll see they're actually depositing on the point bar because the outer edge or the outer bank is the cut bank, is where it erodes and it deposits the sand and material on the inner point bar. But we can actually see in cross-sectional view this pinching and swelling of these units here, which lets me know that this is actually an ancient channel deposit from 150 million years ago. And some more dinosaur bones. I will just take a second and pan up this beautiful valley here in Colorado on the Front Range. With these bones sticking out behind me here in the Morrison Formation, I want to say thank you all for joining me today to check out Dinosaur Ridge. This was by far one of my favorite adventures I've taken with you all ever. I'm so excited I could share so many unique things with you. The #1 track site, one of only 12 theropod tracks, the cross-sectional view of those sauropod tracks were amazing. The fact we can actually see bones in situ, in place, and talk about the geology that deposit them here, telling us that the dinosaurs were living along these rivers, really, really cool. So with that being said, if you enjoyed this video, please give it a thumbs up. If you want to learn more about geology, paleontology, and history, please subscribe to my channel to keep up on all of my adventures. I'm going to be going on some additional adventures here in Colorado, and I will be posting those following this one. So with that being said, thank you all for joining me. Thank you all for learning with me. I will catch you all in the next adventure. Take care.